let's go and review a couple of the key concepts from yesterday before we get to your homework. We began looking at the most basic shape of all, class, and that would be the straight line. With a straight line, you can make literally infinite number of polygons out of it. So we're talking about the straight line for starters, and two key things about straight lines we looked at yesterday. One of them was finding the length of a straight line. We had a formula, but we didn't call it the length formula. What was the formula we would use to find the length of a line? Quentin? We didn't use the term length, but how do we define the length of a segment? James? Yeah, there we go. Distance between endpoints. Okay, so we didn't call it the length formula, we called it the distance formula. Either of you, what is that distance formula from yesterday?
Change in x squared plus the change in y squared square root.
There we go. That's how we mentally think of it, right? Change in x squared, change in y squared, take the square root. If we were saying it as a formula, we'd say d equals the square root of change in x squared plus change in y squared. Let's say that together as a class. Distance equals the square root of change in x squared plus change in y squared. And then another formula we looked at that has, okay, maybe not as many uses in the geometry sense, but we found a couple uses for it. Dig up a couple, right? And that is the point that's at the very middle of a line segment. What do we call that point?
Midpoint.
The midpoint. And the formula for the midpoint, remember I said essentially, you're simply going to average all of the x's to get your abscissa of the midpoint, average all the y's to get the ordinate of the midpoint. I said, really, you just do that with the endpoints. So what is my formula for midpoint, class?
x1 plus x2 all over 2.
And y1 plus y2 all over 2.
Good teamwork, y'all. The key thing to remember, this is the hard mental adjustment. Whenever you're finding a change, right, you're finding how far apart on the number line they are, right? So technically what you're doing mathematically is you're subtracting values. Here you're adding values. So it's not a change in x divided by 2. There's your change in x. Here you're actually adding the values together. So if we had a couple of randomly named points like Q and A, doesn't stand for question and answer. If I wanted to find the length of QA, this is how we notate it, remember, D sub QA. If I wanted to notate the midpoint of QA, we would do capital M sub QA. And that would be to find the length or distance of line segment QA and the midpoint of QA. We could also find the length of JN and the midpoint of JN, or the length of GH and the midpoint of GH. At your seats, I want you to find all three lengths, all three midpoints. And then we'll take a look at that homework. They kind of built on these concepts, but took them a little further and tied them back into geometry from last year. Finished. And Quentin finished? All right, let's see how we did here. On the length of QA, what did you get?
5 units.
5 units, even, the square root of 25. And then for the midpoint of QA, you had,
5, 2.
you're right, I got the 5 you have, but I didn't get 2. Add and divide by 2?
Oh, 5 halves.
5 halves or 2.5 would be easier to graph. Nothing wrong with a 5 halves though, or a 2.5, any of those would work. Jamie, on the length of JN, you had 10 units. And then for the midpoint of JN, you had
1, 3.
1, 3. All right, and then for the length of GH, what did we get for that?
Square root of 34.
Okay, the square root of 34 units. That's what, approximately, I'm going to guess like 5.8. Someone fact check that? 5.8 units?
5.83.
5.83, perfect. All right, so about 5.8 units. You don't have to do the approximation necessarily, but helps us to think in terms of comparing that length, for instance, to the others. And then what about the midpoint of GH? Jamie, what did you get?
5.5 and -1/2.
Good, 5.5, -1/2. You could have 11 halves here. You could have 5.5 here. You could also have -0.5. By the way, if you do a decimal for one, do a decimal for the other, right? If you do a mixed number for one, do a mixed number for the other. If you do improper for one, well, in this case, there wouldn't be improper for the other, but just make sure you kind of keep it logical, right, in the way you express your answers. Questions at all on distance and midpoint formulas? All right, this is the basic approach, and this is frankly what we did in Algebra 1 and Algebra 2. But we're in pre-calculus now. So we do like what you did on the homework. As you open up your books to page 204, we can now apply all of these concepts to geometry concepts that we've learned. Go ahead and read problem number 4. You did 4B, 5B, and 7B. Read number 4 for us, if you would, Jamie.
Show the quadrilateral UVWX is a parallelogram.
All right, and so they give us 4 points. They want us to show it's a parallelogram, so I'm going to draw it like it is. And again, drawing a sketch is always a good idea. They gave us the point U was
2, 3.
2, 3. V,
4, 6,
W,
7, 1.
7, 1.
Yep.
And X was the next one, right?
5, -2.
All right, not drawn to scale, but we don't care, right? We don't trust our eyes anyway. All right, this is just for a frame of reference here. And there's 2 ways to prove it's a parallelogram. Which way did you do it, Quentin?
I found the lengths of the
4 sides?
4 sides.
All right, so if we show that UV and XW are equal lengths, distances, and we show UX and VW are equal lengths, that would prove it's a parallelogram. Did you do the same thing, Jade?
I did both the lengths and the diagonal.
Oh, you also did the other. Okay, so I'm going to show both ways. Let's start with the lengths, though. What was the length of UV, Quentin?
Square root of 13.
Square root of 13. For VW, what did you get for your length, Jamie?
Square root of 34.
Square root of 34. What did you get for the length of XW, back to Jamie?
My square root of 13.
All right, and then for UX, Quentin?
Square root of 34.
All right, so by showing this, it shows it's a parallelogram. Again, the alternate method would be to say, well, if you were to draw this diagonal and this diagonal, if it's a parallelogram, what will be true of those diagonals?
Well, I just have an endpoint.
They'll bisect each other, meaning they will intersect at each other's midpoints. Now, this is not drawn particularly well. I think maybe it's not actually a perfect parallelogram, or I just can't draw straight lines, but it doesn't look like this is the midpoint of VX. It doesn't look too bad for UW, but anyway, we don't trust our eyes, so it doesn't matter. Let's find the midpoint of right here. So remember, we're going to add and divide by 2, class. 9 halves. And here, add and divide by 2. 4 halves are 2. Well, if we do the same thing here, we add and divide by 2.
9 halves.
9 halves, add and divide by 2. 4 halves are 2. So by showing that the midpoint of UW is the same thing as the midpoint of VX, and we've shown they bisect each other, that's another way to prove it's a parallelogram. You didn't have to do both, but you'd have to do at least one of those. And if you did do both, smiley face on the paper, but no extra credit. I'm stingy. Questions on this? Pancake, but no extra credit. All right, questions. All right, let's go on to number 5. Read number 5 for us, Quentin.
Show the triangle XYZ is isosceles.
All right, so we draw a triangle. Again, isosceles means, class, two equal sides. We don't know which two are equal yet. It doesn't really matter which two yet. And for letter B, it was triangle XYZ, and point X was,
-1 and 5.
Y was,
3, -4.
and Z.
12, 0.
12.
All right, again, not drawing a scale, we don't care. We're just going to find the lengths of all three sides, and if two of them are the same, it's isosceles. Let's start with the length of XZ. And what do we get here, class?
Root of 46.
I'm getting the square root of 194. Hold on, so that's a 3rd change of 13, it's 169. Change of 5 is 25. I'm getting 194. And I don't know if that reduces or not, but you know what? I don't even care. Because if there's another square root of 194, I just know it's isosceles, right? Whether or not I reduce it, I've proven it's isosceles. Let's take a look at YZ. To find the length of YZ, more big numbers. What do we get here, class?
Root of 97.
Oh, that's right. I was thinking 15. That's if I add them. 9 is the change. 81, 16, square root of 97. There we go. I had like a 200 something. I'm like, man, that's awful. All right, square root of 97. Helps to do the right math. All right, and here, 4, 9, yeah, 16. 8. Oh, there we go. Another square root of 97. So my two equal sides are?
ZY and XY.
So what are my equal angles?
Angle Z and X.
Angle Z and angle X. It didn't ask for the equal angles, but that shows it's isosceles. Did we get YZ and XY equal in the homework? Excellent. Then number 7B. Read number 7 for us, Jamie.
Find the length of the altitude on the non-equal side of isosceles triangle ABC. Recall that this altitude of an isosceles triangle bisects the base.
All right. So once again, we know they tell us it's going to be isosceles. So we're going to get two of these sides equal. Once we know which two, if it's these two, for instance, we draw the altitude between them. If it's these two, we draw the altitude between them. If it's these two, we draw this altitude. Right? And we know that the altitude in an isosceles triangle goes to the midpoint of the non-equal side because it bisects the non-equal side. So we need to find, we're on number 7, so we got A, B, C. We need to figure out which is the non-equal side, first of all. Which one is the base, if you will, and which two are the legs. Point A was?
-5, -4.
-5, -4? Okay, just make sure I heard it correctly. B?
7, 1.
And C.
-10, 8.
That one? All right. And so B comes out evenly. 13 units. BC does not come out evenly. It's big. 17 squares, that's 289. 7 squared, 49. 289, 49, 338.
Yeah.
Square root of 338. That probably reduces, but I don't care. AC, come on, 13. Yeah, that one comes out to the 13, doesn't it? All right, so these are my equal sides. This is my base, so I'm going to draw that altitude there that's going to go, if it's the altitude, it's going to go to the midpoint, we said. And the midpoint is, oh man, it's going to be
3 halves, or -3 halves, and +9 halves.
Yeah, now if you were graphing this, you'd want -1.5, 4.5, right? Mathematical purposes, we don't want the mixed numbers. So it doesn't look pretty, but it's a lot easier to do math with. Make sense? So we're going to leave the -3 halves, 9 halves. Did we get that for the midpoint of the base?
I had 8.5.
Ooh. For which one?
The X.
The X. Oh, you added to get 17.
Oh.
Instead of realizing that a -10 plus a +7 gives -3. That's why. All right, so your answer is going to be off then. So I'm going to ride with you here, and you're checking your answer. The actual question it had was, what is the length of this altitude? The line from A to the midpoint of BC. Now, here's the fun part. To find this change because of the fraction is really annoying. So here's a strategy tip. If one of them's a fraction, make these fractions as well. Instead of a 5/1 and a 4/1, let's rewrite point A with the same denominator of 2. So -5 becomes -10 halves, and -4 becomes
-8 halves.
it's going to be easier to calculate the change in x if you have negative 10 halves, negative 3 halves. What's the change, class? 7 halves, which we're going to square in just a minute. And then 9 halves, negative 8 halves. What's the change? A change of 17 halves. And again, we're going to square that in just a moment. So here we're going to take the square root of, well, square the bottoms first, because it's easier. And I'm lazy. Square the top, not bad. Square this numerator. It was one that we memorized. 289, one that we haven't seen in a little while here. And we add that, and interestingly, we get the square root of
84.5.
well, the square root of 338 fourths, which I might be able to, does this divide by, no, it doesn't divide by 4 evenly. That's a shame. I could reduce it down, but remember, I want to take the root of the denominator. Remember, we talked about having a rational denominator. So what's the square root of 4? 2. Can I reduce, because this is my final answer, so I do have to reduce it if it does. The square root of 338. 4 doesn't go in. Does 9 go in?
No.
16 won't, 25 doesn't, 36 doesn't. Does 49 go in? Can you divide that by 49?
No.
I got a yeah and a no.
Not evenly.
Not evenly. Okay. 64, no. 81, maybe? Does it divide evenly? No, it won't. 100, 121? I'm running out of numbers. 144, no. 169? Oh.
Yes.
Yes, there we go. Okay, so this factors, 169. Normally after the first few don't work, I resort to try divide by 2, divide by 3, divide by 5. But should have done that. All right, so the 169 gives me a,
13.
so we end up with 13 times the square root of 2 all over 2 units. And that's our ugly answer. Whew. Questions on that? We hadn't seen this in class yet last time, because the last problem worked out a lot nicer than this. Does it make sense getting the common denominator of 2 to make the changes easier to calculate? And if they're both 2's, when you square them, they're both going to be 4's, which actually works out great because you don't mind a 4, because you don't have to multiply by anything to get your nice, easy, rational denominator. But that was kind of ugly. I'm not going to lie. That was ugliness. Questions? All right, well, let's take a look at a couple more here. Let's go down to number 8. And read number 8 for me, if you would, whoever didn't read the last one.
Show that the line joining the midpoints of any two sides of triangle UVW is equal to 1/2 the third side.
Ah, okay. So let me take you back in your geometry minds here. We have a triangle. We plot a midpoint, we plot another midpoint. And we connect the two midpoints. This is not the median of the triangle. Remember, a median is vertex to midpoint. This line doesn't have a name. So we called it last year the no-name line. Do you remember the no-name line? Always joins the midpoints, it's always parallel to the third side, and equals half the third side. Now, that was a proof that was 23 steps. It was in your textbook, so we didn't do it in class. We're just like, look at the proof. See that? Crazy, isn't it? Let's just trust them and let's move on. All right? But, of course, there's technically 3 no-name lines you could draw. I could draw this no-name line. I could draw that no-name line. And every time it's half of that side. This is half of that side. This is half of that side. And, of course, parallel to that third side. Well, we're going to show it mathematically now. Draw a triangle, any triangle. A bigger is better because it gives you room to write in and around it. And it gives us the name of this triangle. Is it UVW, you said? Mm-hmm. UVW, where U is, let's go to part A.
7.5.
7.5. Okay, V.
1 -3.
And W.
3.7.
3.7. All right, we want the lines that join the midpoints. So guess what we're going to have to find? The midpoints. So let's find the midpoint of UW. Let's find the midpoint of UV. And let's move. And let's find the midpoint of VW. At your seats. Find all 3 midpoints. Once you're done, check your 3 midpoints. Are we good on all 3?
One in my head negative, but I see.
Okay. All right, good to go now. All right, so we got that fixed. You were good to go already. All right, it wanted us to show that this no-name line is half of this line. Well, to show that it's half, that means we're going to have to find the lengths of both lines. So we're going to need, check out the notation here. We're going to need to find the length of UV, dov, and we're going to need to find the length or the distance from the midpoint of UW to the midpoint of VW. I like all that sub-notation. Does it make you feel smart? Like, hey, I know what that means, you know? Random stranger walks in, what in the world are they doing? That looks crazy. I'm like, nah, that just means like from that point to that point. At your seats, find those 2 lengths. All right, questions on those first 2? Did you get those lengths, 5 and 10 respectively? Double checking some things. Oh, I wrote them backwards.
Yeah.
Sorry, I looked at the top one and I put it here, but for some reason I wrote the bottom one. Yeah, sorry, these are backwards. I'm going to do, this one's 10, this one's 5. There we go. That one, and that one. All right. I was just seeing if you were paying attention. Good job. All right, questions now. All right. So that shows that this no-name line is half of its side. But there's still 2 other no-name lines. So let's make this no-name line and compare it with this one. So let's find the distance from the midpoint of UW to the midpoint of UV. And let's find the distance from V to W. This one doesn't work out quite as nicely. All right, do we get those lengths? Square root of 26 and square root of 104 looks way bigger, right? It looks like it's 4 times as big. But remember, when you factor in the 4 times 26, you actually get the 2. So 2 square root of 26, yes, it's twice as big. Or you could say that the square root of 26 is half as big, half the third side. All right, our final no-name line is this one. And we're going to compare it, of course, to its opposite side. So let's find the length of distance, rather, from the midpoint of UV to the midpoint of VW, and compare that to the distance from U to W. Good. And good to go. All right. So again, does this necessarily prove? No, it's not proof, but it's demonstratable, right? It's demonstrating the truth of what we'd already, well, the book proved last year in geometry class, because, lazy. Questions on this? All right, let's go down to number 10. And what are we going to do in number 10 on some of these different figures we're looking at? Jamie?
We'll be proving that it's a right triangle.
Prove that it's a rectangle?
No, right triangle.
Right triangle. Okay, prove that we have a right triangle. All right, now, obviously 3 points is going to make a triangle, correct? So as I look at, for instance, letter A, right? I know it's going to be a triangle because there's 3 points. I don't even want to draw it as a right triangle, though, because I don't know where to put the right angle, and I don't want to be wrong. So I'm going to just, once again, kind of draw equilaterally. Do that at your seats as well with me. And as we do letter A, they give us the coordinates. Let's see, -4, -1 for A, 2, 7 for B, and -5, 6 for C. Isosceles makes sense. Just show 2 sides are equal. Equilateral would make sense. Show all 3 sides are equal. Scaling would make sense. Just show that 2 of the sides are, or none of the sides are equal. How would I show right triangle?
One side is double the other side.
Well, is a side double the other in every right triangle? In a 30, 60, 90 it would be, right? You could get the one side double another side and still longer than yet. Well, but then it would have to specifically be square root of 3 times that other length. That's, Because all we got is midpoint and lengths, right? Now, if it's a right triangle, and I found the 3 lengths, I could tell a little bit from those 3 lengths, right? What could I tell about them?
The sizes.
Right, so if it's a right triangle, I know the longest side would be and the other 2 would be the legs, correct? But that wouldn't necessarily tell me that it is a right triangle.
Does it have to do the altitude again?
Well, I suppose if we found the midpoint of the long side, we find 3 different lengths, right? One of them's really long, okay, or longer than the others. We call that the hypotenuse, right? Find the midpoint if, let's just say, for sake of illustration, that this is the right angle. If we found this midpoint, this length and this length, of course, are going to be equal to each other. But if this length is the same as these lengths, then it is a right triangle. That would be one way to do it. There is an easier way, but that way would work. You said that does it have to do with the altitude? It has to do with a median, not necessarily an altitude. Again, we said the longest side, if we found the 3 lengths, the longest one would be our, and the other 2 are called the legs.
Hypotenuse equals the sum of the square of the legs.
Yeah. If this is true. If the square of the big one equals the square of one of the little guys plus the square of the other little guy, it's got to be a right triangle, correct? Because all right triangles satisfy the Pythagorean theorem. So if it satisfies the Pythagorean theorem, it's got to be a right triangle. So, I should probably erase this as well because I don't know where the right angle is yet. So let's start by figuring out the 3 lengths. Let's figure out the 3 lengths. Let's find the length of AC first of all. Call it, when you got it.
Square root of 2.
5 times the square root. You initially get square root of 50, don't you? And that becomes 5 times the square root of 2 if you were to reduce it down. All right, now let's find the length. Did you get that, Clinton?
Yes.
You just said it backwards.
Yeah, I did it.
I heard 2 times the square, so I'm like, that's not right. And I was like, maybe he was just saying it backwards. We'll give you the benefit of the doubt. All right, so find the length of AB and call it, when you've got it, 10. Did you get that? All right. And now let's find the length of BC and call call it, when you got it, this is going to be another 5 times the square root of 2. Now, one thing that may make our life easier is if we think of this in terms of the square root of 50. And if we think of this as the square root of 100. So if we actually think of them in their radical senses, it makes them easier to square. It also makes them easier to compare. Because our brain doesn't think 5 squared of 2, right, is about 7, right? We don't think that that's about 7. We're like, 5 squared of 2, what's that, right? Which of these is the longest side? AB, AC, or BC?
AB.
AB. So if we take this length squared and say that's equal to this length squared plus that length squared, well, obviously when you square square root, you get the radicand. And so 100 equals 50 plus 50? By the way, not only is this a right triangle because it satisfies the Pythagorean theorem, 2 sides are equal. So it's an isosceles right triangle. By the way, here's the right angle. Here's your equal legs, which means this is a 45, 45, 90 right triangle. Now again, not drawn to scale, obviously, but that's what it's got to be. And there we go. The Pythagorean theorem proves that. Questions? All right, let's go to letter B. Same thing, just different vertices of our triangle this time. Letter B. And call out the 3 vertices for me if thou wouldest.
A is 3, 5. B is 3, negative 1. And C is 7, negative 1.
So this is they have the same y values. This is a horizontal line. This is the same x value. So this is a vertical line. So this has got to be the right angle here. Do you see that? This has got to be horizontal. This has got to be vertical. So these have got to be perpendicular to each other. But let's let the math confirm what I speculate. All right, let's find the length of AB. 6. Let's find the length of BC. 4. And let's find the length of AC. I'm getting square root of 52 also. It could be 2 times the square root of 13. I'm just going to leave square root of 52. All right, let's see if this works. This is the longest, right? Because this is really the square root of 16. This is really the square root of 36, correct? So this is my long side. If I square that, I would get 52. Square this, of course, I get 36 plus square that, 16, yay or nay. And in fact, this is the right angle. This is the hypotenuse. Now, it's not an isosceles right triangle like last time, but it's a right triangle nonetheless. Questions on 10b? All right, just 3 problems for you for homework tonight. I want you to do, on page 204, 8b and 10 C and D. 8b and 10 C and D. Using midpoint and distance formulas in our geometric figures. Have a wonderful rest of your day. And you are dismissed.